Example 4 says, below is a table of the 2020 federal income tax brackets for a single filer in the United States. These are the actual numbers from the IRS, and we want to use it to answer the questions below. Before we start part A, note that it appears that there is a jump in taxes when a person starts to make more than $40,125. So, notice from 10 to 12, you're increasing by 2 percentage points, but after you've started making more than $40,125, it appears as if there's a larger jump in the taxes that you are paying. So that's something that we want to address at some point when we're going through this example. So keep that in the back of your head as you are going through this example. And also think about, have you filed taxes before? How much did you have to pay in taxes, or did you get a refund? Things like that. Okay, so part A says use the table and write the function that gives income tax for a single filer as a function of taxable income x. Only consider values of x that fall between 0 and 163,300. So we are making a piecewise function for these values here. Anything after that, that's for the mega rich people, and we're going to ignore those values for now, and we are only concerning ourselves with the first 4 columns of our table. So I'm going to call our function t of x. So I'm going to say t of x equals, and we want to come up with the first subfunction of our piecewise function. And x represents our taxable income. So those would be like the values that fall between $0 and $9,875. And in that first interval, the way that we're calculating our tax, the tax that we're required to pay, is we're taking 10% of whatever our taxable income is. And that is taking place on the interval from, if you're making anywhere between $0 and $9,875. So that is how we would calculate our first subfunction. Now, in order to calculate the next subfunction, we would want to create a new function down below. And basically, if you've made the maximum in that tax bracket, which is $9,875, you're going to be liable for a tax of amount of 10% of that number, 9,875, which if you take 10% of that, that is equal to $987.50. If you don't believe me, you can open up a calculator. So we have 9,875, and we're taking 10% of that. So that gives us $987.50. So after you've made an amount higher than $9,875, you are going to be paying $987.50 plus 12% of whatever you're making above that amount. And so the way that you would calculate that is it'd be x minus 9,875. And so that is happening when x is greater than 9,875 and less than or equal to 40,125. Okay, I am going to write out the rest of the last two subfunctions, and I want you to think about how I'm getting these numbers, and maybe pause the video here and see if you can come up with the two subfunctions on your own. All right, so I've gone ahead and I've filled out the rest of our piecewise function, and that is basically all this question is asking for. However, I thought it'd be kind of cool to see what tax liability the average the average American would have. So I went ahead and I went to the internet and looked up the personal median income of the average American. And according to the US Census Bureau, in 2019, the median personal income in the United States was $35,977. I'm just going to round that to $36,000. So again, median income was $35,977. I'm just going to round that to 36,000. So it'd be interesting to see how much taxes a person that made $36,000 would owe. So basically we are evaluating T of 36,000, and we are going to use the second subfunction since 36,000 is greater than 9,875 but less than 40,125. So that's going to be 987.50 plus 12 times 36,000 minus 9,875. And I'm just going to throw that into a calculator really quick and see what that gives us. So I went ahead and I plugged that into a calculator, and it turns out that the average American would pay $4,122.50 in taxes for 2020. All right, so part B says, is the function in part A continuous at x equals 40,125? And in order for it to be continuous at that point, we need to satisfy those three conditions that we talked about at the beginning of this section. So the first thing that we need to check is condition 1. We need to check that T of 40,125 exists, and it does. Let's see what it is. So if we plug that into our second subfunction, we get 987.50 plus 0.12 times 40,125 minus 9,875. I plugged that into my calculator earlier and got that that was $4,617.50. I'll put a little dollar sign there. And so our first condition is satisfied. Our second condition says that the limit as x approaches that value must exist. And so what we're going to need to do is we are going to need to calculate the limit from both sides. So we're going to calculate the limit as x approaches 40,125 from the left-hand side, which we're going to use the same subfunction, and it turns out it's going to equal this thing. And so the limit from the left, because that's a linear function, it just turns out to be what we just calculated earlier. And then we need to calculate the limit from the right-hand side. And in order to do that, we're going to use the third subfunction. So we have 4,617.50 plus 0.22 times 40,125 minus 40,125. So recognize that this is equal to 0, so this whole thing here is going to turn to 0, and the right-hand side limit is 4,617.50. Now recall, since both the left-handed and the right-handed limit, since these are equal, that means that the limit does exist. So that checks off, the first condition checks off. And then the third condition was that we need T of 40,125 to equal the limit as x approaches 40,125 of T of x, and we've met that condition because both of those are equal to $4,617.15. So all of that work just to show that T of x is continuous at x equals 40,125. So if you're doing homework problems like this, you do need to show all of these steps and that all three conditions are met. So keep that in mind when you're working on your homework. The last part of this example says, your friend says that she currently makes $40,000 as her annual salary, but doesn't want to make any more than that because doing so would place her in a higher tax bracket. What would you tell her to do if she is offered a raise? Basically, what you want to tell your friend is that she'd only be paying a higher percentage of her income on anything she makes above $40,125, and she'll still be paying the same amount of taxes on anything up to $40,125. So if she's offered a raise, your advice to her would be that she should take whatever raise that she's getting. So again, just to reiterate, if you're looking at the tax brackets, she'd only be paying 22% on anything above $40,125, not, and I think this is maybe a misconception that certain people have, is that you're not paying 22% on your total income, just on the amount that is above $40,125. So again, you would definitely want to tell your friend to take the raise.